Hey community people, welcome back to our YouTube channel Tech Begin, and today is day 5 of learning Python. And as you all know that today our topic is file handling and external libraries in Python. First of all, we will learn about introduction to file operations and module. And our agenda is introduction to file handling, types of file modes, reading and writing files, introduction to external libraries, standard module imports and examples and also use cases. What is file handling? File handling refers to the process of performing operations on a file such as creating, opening, reading, writing and closing it through a programming interface. It involves managing the data flow between the program and the file system on the storage device, ensuring that the data is handled safely and efficiently. It is useful for data storage and retrieval. Built-in open function is used for file operations. Then our next slide is about file modes in Python. When opening a file, we must specify the mode we want to, which specifies what we want to do with the file. And now let us see one by one. The first one is R, and R means read only mode. And the behavior of R is it opens the file for reading, and file must exist, otherwise it raises an error. And the next one is W. Here W means write mode. It opens the file for writing. It creates a new file or truncates the existing file. And the next one is A. A means append mode. It opens the file for appending data. It creates a new file if it doesn't exist. And the next one is X. X means exclusive creation mode. It creates a new file, raises an error if the file already exists. And the next one is B. B means binary mode. If we want to write any binary code, then we can use this B. And the normal default mode is text mode, and text mode is indicated with T. The next slide is about opening and closing files. To open file in Python, we can use the function open, which requires the path and mode as arguments. This code opens file named. If we give any name, then it opens that file. Here we can see the example file is equals to open example.txt, and we gave in read mode. The name of the file is example and it is in the mode of text, and we opened as read. So here open is a function which is used to open the file. And again we gave data is equals to file.read, means the file which is opened, it should be read, and that's the reason we gave read as a function. Then at last we used file.close. So now let us discuss about closing files. Closing a file is essential to ensure that all resources used by the file are properly released. So we used .close as the function. It closes the file and ensures that any changes made to the file are saved. Here in this example we used file.close. Since the file is opened at the start and at the starting line, we should close the file using file.close function at the end of the code. Always close the file to free up resources. We can close this by using with statement. Then the next slide is using with statement. With statement is used for resource management. It ensures that file is properly closed after its suit finishes, even if an exception is raised. With open as method automatically handles closing the file once the block of code is exited, even if an error occurs. This reduces the risk of file corruption and resource leakage. Here we can see the example with in the previous slide we gave file is equals to open. As you can see here, file is equals to open, and at last we closed it by file.close. In this slide we directly gave with open, means if we use the word with before open, then after the code is exited, then it automatically closes the files. So here we gave with open example.text. Example is the file name and text is the mode, and r we gave it in the read form. So we read the file. So data is equals to file.read. Here we didn't use the word dot close because we use the word with. If we use with, then no need of closing the file because it automatically closes once the block of code is exited. Then the next slide is about reading from a file. Reading a file can be achieved by file.read, which reads the entire content of the file. After reading the file, we can close the file using file.close, which closes the file after reading it, which is necessary to free up system resources. And then the read can be also done in two processes: reading a file in read mode, that is R, and the second one is reading a file which is in binary mode. There we used RB. The next one is read lines. We may want to read a file line by line, especially for large files where reading the entire content at once is not practical. It is done by using readline method. Readline reads only one line at a time, while line continues until there are no more lines to read. This method reads a single line at a time using readline, which is useful when processing files in chunks. Here is the example for the method readline. Here we gave file is equals to open geeks.txt, where geeks is the file name. Then we gave line is equals to file.readline. Here we gave read line to read the whole file line by line, and then we gave some conditions, and then we closed the file. This is the example to read the whole file line by line using the method readline. The next one is readlines. The readlines method returns a list containing each line in the file as a list system. Use the hint parameter to limit the number of lines returned. If the total number of bytes returned exceeds the specified number, no more lines are returned. Here is an example for the method readlines. In this case, it returns all the lines in the file as a list where each line is an item in the list object. Since we didn't give any number or anything as parameters in the method. In this example, as we can see, we given the number 33 as parameters inside the readline functions. So it do not return the next line if the total number of returned bytes are more than 33. And that's about reading from a file. Now let us move to the Next slide, writing to a file. To write to an existing file, you must add a parameter to the open function. We can use append or write. Append will append to the end of the file, while write will override any existing content. Here we can see we gave with open, so there is no need of closing the file again at the last of the code. We gave the file name as output, and we wrote w, and we have to write something in that, so we gave w. And what we should write means file dot write. In that parameter we gave hello world, so hello world will be written in the output file. We can use a mode, that is append mode, to append instead of overwrite. This is about writing to a file. Now let us move to the next slide. Our next slide is what are external libraries. External libraries in Python are collections of code developed by external programmers that provide reusable functionality. They are not part of Python's standard library and need to be installed separately. Examples: NumPy, Pandas, requests, PyTorch, Beautiful Soap, Seaborn, Keras, PyBrain, etc. And then how to use them? First of all, import. Use the import statement to bring the library into your Python script. For example, import NumPy as np. Then utilize. Access functions, classes and other objects provided by the library. Then read documentation. Refer to the library's documentation to understand its features and usage. External libraries greatly extend Python's capabilities, enabling developers to accomplish a wide range of tasks efficiently. Then let us move towards next slide. The next slide is why use external libraries. Here are some reasons why external libraries are used in Python. Extending functionality. Python standard library provides a wide range of built-in modules, but external libraries offer specialized tools and functions for specific tasks such as data analysis, web development, machine learning, and scientific computation. And the second one is saving development time. By using external libraries, developers can avoid writing code from scratch for common tasks. This saves the time and effort, allowing them to focus on solving problems rather than reinventing the wheel. Access to pre-built solutions. External libraries provide access to tested and reliable solutions for complex problems. They reduce the risk of errors and ensures that code is efficient and well optimized. The next one is community support. Many popular external libraries have large and active communities of users and developers. This means that developers can easily find help and support when they need it. And the last one is code reusability. External libraries provide reusable components that can be easily integrated into different projects. This promotes code reusability and reduces the amount of code that needs to be written. In conclusion, external libraries are an essential part of Python ecosystem. They provide a wide range of tools and functionalities that enhance the language's capabilities and make it easier for developers to build complex applications. Now let us move towards the next slide. The next slide is standard modules in Python. Python includes in many built-in modules. Python standard library includes a vast array of modules that provide pre-written code for common tasks. These modules are readily available without needing to install any external packages. Here are some of the most frequently used standard modules: math, random, datetime, and also OS, sys, time, collections, etc. The first one is math. Math provides mathematical functions like square root, trigonometric functions, and constants such as pi. Then the next one is random. Random module is used for generating pseudo-random numbers which are useful in simulations, games, and security applications. The third one is datetime. The datetime module offers classes for working with dates and times, including calculating time differences and formatting dates. And the next one is OS. OS module provides an interface to interact with the operating system, allowing you to perform tasks like file manipulation and directory navigation. And the next one is sys module. Sys module provides access to system specific parameters and functions such as command line arguments and the Python interpreter's path. And then the next one is time module. Time module offers time related functions for measuring execution time, pausing execution, and working with the time formats. And the next one is collections module. Collections module offers specialized container data types such as default dict, counter, and named tuple. Now let us move towards our next slide, importing modules. The most common way to use a module is by importing it with the import statement. This allows access to all the functions and variables defined in the module. For example, here we give import math. Math module is imported using import math. From datetime, it imports datetime. Import random as RND. We access the constant. Here is an example. Here we imported math. Import math. Pi is equals to math.pi. In this case, we access the constant pi using math.pi, and then the value is printed as a part of formatted string. And so we give print the value of pi, and in that place we will get the value of pi in decimal form, that is 3.1415. Let us see another one, that is importing specific functions. Instead of importing the entire module, we can import only the functions or variables we need using the form keyword. This makes the code cleaner and avoid unnecessary imports. Here is the example. From math, import pi, and we gave print pi. The output will be 3.1415. So here from math import pi, it imports only the pi constant. So we can use it directly without math.prefix. This reduces unnecessary module overhead when only specific functions or constants are needed. Here are some more examples. Here we gave import math, and then we gave math dot square root of 25, and we know that square root of 25 is 5 and the output will be 5. Here we used the module square math, and in that we wanted square root. The next one is from date time import date dot today. That means date time is the module and we want to import the date of today's. That means we want to print today's date. Hence the output will be June 7th. June 6th will be the output. Here is the another one, importing built-in modules. Python provides many built-in modules that can be imported directly without installation. These modules offer read-to-use functions for various tasks such as random number generation, math operations, and file handling. Here we can see import random and then res is equals to random dot radiant 1 comma 10. Then we gave print random number res. Here import random brings in Python's built-in random module. That means random dot rand int 1 comma 10 generates a random integer between 1 and 10. So here the random number can be any of the number between 1 to 10. Here we got the output as 9, but it can be either 8, 7, 6 or any greater number that is greater than 1 and lesser than 10. And here we got the output 9. Here is the next one, importing modules with aliases. To make code more readable and concise, we can assign an aliases to the module using the as keyword. So as is a keyword that we can use here. This is especially useful when working with long module names. Here is the example. Import math as m. Result is equals to m dot square root of 25. Then we gave print square root of 25 comma result. That means import math as m imports the math module and assigns it to the alias m. M dot square root of 25 calls the square root function using the aliases. So we will get the square root of 25, that is 5. Here is the next example, importing everything from a module. Instead of importing specific functions, we can import all functions and variables from a module using the star symbol. This allows direct access to all module contents without prefixing them with the module name. Here is the example. From math import star, print pi, print factorial of 6. That means from math import star, it imports all functions and constants from the math module. Pi and factorial of 6 are accessed directly without using math as a prefix. While convenient, this method is not recommended in larger programs as it can lead to conflicts with existing variables and functions. So here we will get the output of pi and also the factorial of 6 since we gave it as print form. The value of pi is 3.1415 and the factorial of 6 is 720. So the output will be 3.1415 and the factorial of 6 720. Now let us see some advantages and disadvantages of file handling in Python. First, the advantages. Data persistence. It allows programs to store data permanently even after the program has finished running. This is crucial for saving user preferences, application states, or any data that needs to be accessed later. Then data management. It enables reading and writing data to various file formats such as text files, CSV files, and binary files. The next one is flexibility. It supports a wide range of file operations including reading, writing, appending, and deleting, offering flexibilities in how data is handled. Then logging and error tracking. It facilitates the creation of log files which are essential for tracking program behavior, identifying errors, and debugging. Then next one is configuration management. It allows programs to read configuration settings from external files, making it easier to modify program behavior without changing the source code. The next one is resource management. Using the with statement, it ensures that files are automatically closed after use, prevention resource leaks and data corruption. And then user friendly interface. Python's file handling syntax is straightforward and easy to learn, making it accessible to programmers of all levels. Then flexibility. It supports a wide range of file operations including reading, writing, appending and deleting, offering flexibility in how data is handled. Then cross-platform compatibility. Python's file handling works seamlessly across different operating systems, ensuring programs can interact with files regardless of the platform. Now disadvantages. First one is performance. File handling operations can be slower compared to other programming languages, especially when dealing with large files or performing complex operations. Then error handling. Improper file handling can lead to errors such as file not found, permission issues, or data corruption, requiring careful error handling to prevent unexpected program behavior. Then, security risks. If not handled properly, file handling can expose programs to security vulnerabilities such as unauthorized access or modification of sensitive files. The next one is complexity. Managing file paths, file modes, and different file formats can add complexity to code, especially for beginners. Then overwriting. Using the write mode, that is W mode, can overwrite the existing content of a file, which can lead to data loss if not handled carefully. Then the next one is large file sizes. Appending data to a file can lead to large file sizes over time, which may require additional management. Then resource leaks. Forgetting to close a file can lead to resource leaks, which can cause performance issues or program crashes. Then limited control. When using the with statement, there is less control over file handling outside the block. So these are the advantages and disadvantages of file handling in Python. Now let's move to the next slide. The next slide is conclusion. File handling is essential for persistent storage. The external libraries enhance Python's functionality. It uses standard modules for common operations. Then the next slide is the last slide. So until here we completed today's topic, and if you have any doubts or any queries, you can comment down in the comment box. Thank you.